So we're going to find the angle between two planes. And before we do this specific example, just to show in general, if we have two planes in 3D space, so here we have the orange plane is just the xy plane, and what we want to find is the vectors that are normal to each plane. So that means perpendicular to each plane. So the xy plane would be perpendicular to the z-axis, and the blue plane would be perpendicular to this vector here. And if we can find the angle between those two normal vectors, then that actually gives us the angle between the two planes. So that may seem obvious or not obvious, but to explain why that actually works, remember to measure the angle between two planes, we need to measure perpendicular to both planes. So if the orange plane is the ground, for example, when we measure the angle, we need to measure directly up from the ground. And that is the same direction in which the angle between the normal vectors is measured. Okay, so it's in this plane, which is perpendicular to both planes and perpendicular to the line of intersection. So that's the idea with measuring the angle between two planes using the angle between the normals. Just one thing to be aware of is if our normal vectors are going in opposite directions, then what we would have between the two normal vectors is an obtuse angle like this. But between our planes, we would state the angle as an acute angle. So all we need to do then is just subtract that obtuse angle from 180 to get the acute angle. Alright, so I hope that concept makes sense. Let's go back now to our example of the two planes that are given. X plus 2y plus 3z equals 0 and 2x minus y minus 2z equals 3. Okay, so here are our planes, and remember we want to measure the angle perpendicular to each plane, so that's perpendicular to the line of intersection. So if we hide the axis, it'd probably make the planes a bit easier to see. And remember, the key thing is we need to find the vectors that are normal to each plane. And from the forms that we're given, that's quite easy. Okay, x plus 2y plus 3z is normal to 1i plus 2j plus 3k. And 2x minus y minus 2z is normal to 2i minus j minus 2k. And to find the angle between those two vectors, we use our scalar product formula. So cosine theta is equal to a dot b over length of a times length of b. In this case, the dot product on the top will be 2 minus 6, and then on the bottom we've got Pythagoras theorem to find the length of each vector. Now you are going to need a calculator for that because you're going to need to take the inverse cosine, and that's going to be 122.3 degrees. Now that's an obtuse angle. So as we said before, this is a case where we want the acute angle. So subtract from 180, that's 57.7. And there it is on the diagram. And that 57.7 is going to give us the angle between the two planes. And there's the angle between the two planes, measured perpendicular to both planes, perpendicular to the line of intersection. And there it is. So hopefully that helps to visualize and understand why the angle between two planes is equal to the angle between the two normal vectors. And if that angle is obtuse, we subtract from 180 to give the acute angle. That's pretty much it, people.